guys, we did a video already about ASUS cable and you had some questions, you have some doubts, some of you, not many. Okay, the thing that you told me, Aris, you should make the bad connection between the bridge and the GPU connector, right? That's why me and Thomas, we worked on something different now. We will actually simulate the bad connection between the bridge and the GPU connector, the connector on the GPU side. But guys, I didn't want to make anything that will interfere with the cable, because if I cut the wires here and put some resistors, automatically I intervene with the cable. So load distribution can go bad, because I actually mess with the circuit. Whatever I do, I have to be sure that the cable remains intact. And as you can see, the cable is intact. I didn't touch the cable. I only installed two thermistors here to monitor temperatures. So what I did, I took another cable, a female one, 12 gauges, 6 power, 6 earth. They go to 6 electronic loads. And what I'm going to do now, I will simulate a bad connection. That will be easy. Yeah, Thomas, let me do that. That's the thermometer. The thing that I will do now, I will apply unequal loads. I will apply 17 amps on these three, which represents the 3 side connectors, and the rest of the connectors, I will only apply 1 amp. This will be a highly unbalanced load, which will simulate actually a bad connection. And that, again, without touching the cable. Because if you touch the cable, you cut wires, you do whatever to the cable, automatically you lose the whole idea, the whole picture. Okay, so ASUS says that the cable can start 17 amps. I will put 17 amps on the 3 side loads, and the other loads will only remain at 1 amp. So in total, 53 amps. I think that's enough. And on the same time, I will monitor the temperature here. I have 2 thermistors on the sides, between the bridge and the GPU side connector. So let's start it. Thomas, how long to leave it like that? So 17 amps, 17 amps, 17 amps, 1, 1, 1. Let's see. We have action, Thomas, already. This simulates perfectly a bad connection. 3 of the side pins are partially inserted, so they have a resistance of 0.02 ohms or 0.025 ohms, and the other 3 are perfectly connected. What that means? That the perfectly connected pins handle most of the current, while the bad pins don't handle any current at all. This is a perfect example where you do something right, but you are screwed. The bad connectors are lazy, don't take any load. The good connectors take all the load for themselves. So 17 amps, 17 amps, 17 amps. Do not pay attention, guys, to the voltage. We only care about amps here, because these loads don't have remote sense. That's why the voltages are so low. 1, 1, 1. Okay. 62 degrees. Stathi, keep a timer, please. We started 30 minutes ago, 30 seconds ago. So how long?
1 minute should be fine.
1 minute. Let's leave it longer. 10 minutes, 15 minutes.
Okay.
Ambient is 25 degrees Celsius, because that plays a role also. 26 actually, the ambient, okay. So guys, again, we simulate a bad connection. 3 pins handle 17 amps, the 3 other pins only 1 amp. In total, 54 amps. 51 here and 3 amps here, 54 in total. So far 70. Now, why there's a difference here? Because the one is the good side, which handles most of the amps, and temperature is increased, while the other side, the other 3 pins, only handle 3 amps. That's why they remain at merely 49 degrees Celsius. And that's the best. Stuff is around 10 minutes, I think. What do you say? I think 10 minutes is enough to prove a point. Guys, if in 10 minutes we don't have dangerous high temperatures, I think these connectors melt around 180, 120, 130. So, if after 10 minutes we are still lower than 120, I think it's okay. And again, this is continuous full load. In your system, you won't have a GPU constantly pulling all the time 600 watt because you would just have spikes. Most of the time, I think it depends on the application, on the game, but it's very difficult to find an application or a game where you will be constantly 600 watt. Now, I don't know if you will use some AI shit or that. Okay, that's up to you. So guys, in your expert opinion, I have two guys here, Stathis and Thomas. Stathis is the, sorry, Dixon. Stathis is the keyboard reviewer and mice reviewer, and he knows his shit. So, Thomas. So guys, what do you say? If it survives 10 minutes, 70 amps, it's okay the cable according to your opinion? Because you are also expert in this shit.
Sure, if it will survive, of course.
If it will survive, yes.
But
so it is, but
yeah.
definitely the product at $50, I think it's expensive, right?
Sure.
Cause sales,
point, yeah.
cause sales is $25. I think that they should put it $25. Wow, it's a good, an okay price, but $50, come on, it's overpriced. If it's, guys, if it stabilizes at some point and, at first it rises high, in a high pace, but, if at some point it stabilizes, it's no point, to go, yeah. And as you can see, the temperature actually is it's low enough. Okay, it's a little bit hot. It makes sense, guys. Say 87, it's almost 100, yeah. But I still can't touch it. And we don't see any melting of shit. And okay, this is a highly unbalanced scenario. Having 17 amps on 3 pins and only 1 amp on the other side. That's a very, in my cable, it will have shut down the system already. Guys, one more thing. I see many of you using IR cameras and other shit to measure the cables. No, that's not the best, the ideal way, the correct way to check temperatures. Because you have to take into account the emissivity factor, and I'm pretty sure that most that use IR cameras don't dial in the proper emissivity factor. The best way to check temperatures is using the old but way more accurate temperature logger, thermometer, anyway. So we are around below 90 degrees Celsius. Stathis, how?
5 minutes now.
5 minutes. Okay, 5 minutes. Thomas, in the previous video we did, I think it reached more than 130 because I barely touched it and went 130. It should go yeah, guys, it was 52 amps in a single gauge. Okay.
Just touch the probe there in the.
It went boom.
The cable.
But you said, I know, guys, what the heck they are telling me about that. I think that the standard cable now, it would have melted. The connector, the pin, because the pin is very difficult. Currently now, we are pushing 17 amps. And you can see clearly that it's 70 amps. You don't need a current clamp to know that because you have the shorts. The shorts tells you that, okay, hey guys, I give you 17 amps per pin. I told Thomas to cut the cables exactly the same length, Because if a cable is shorter, the other is longer, always the current uses the less resistance path. That's the way how current works.
Okay. 8 minutes now.
8 minutes. Guys, in 10 minutes, we'll 10-minute experiment because there's no point. It's way below 120 degrees Celsius that it's typically the melting point, the highest limit of this type of connectors. It's 10 minutes, full load, continuously full load, okay? It's very unlikely scenario that in a real system you will have the GPU hitting 600 watt continuously all the time. You will have some very small periods where the load drops, okay? Because of the application, because of million reasons. Even that millisecond that the load drops, it gives enough time to cool down a bit. Now it's way more stressful that we apply continuously 600 watt. That's why I didn't use a real system. I didn't want to use a real system. I want to use electronic loads because that's the more accurate way to provide, to give the best, the worst possible scenario.
9 minutes now.
1 minute more. Now, if you go and tell me, hey, Adji, why you didn't keep it for hours? I can tell you that the guy who made these cables, he told me that he tried them for 24 hours, I think, or more. Yeah. Guys, I'm sorry, I cannot do that. Electricity in Cyprus is very expensive. €0.5 per kilowatt hour. So, yeah. It's stabilized.
Yeah.
Yeah, so that's
So there's no point. Guys, from the moment it stabilizes the temperature, it means that it reaches the point that it won't go any higher. Or if it goes any higher, it will be a very small change. So there's no point to continue and apply the load. The thing is that I can still touch it. Yeah. I can still touch the connector. If it was
10 minutes.
close to melting point, try it. Try it.
Yeah.
Yeah. It's
We have done 10 minutes.
so that's the ASUS cable, 17 amps, unbalanced loads, 3 pins handling 17 amps. This is what why I selected 17 amps, because ASUS mentioned 17 amps. Okay, in their marketing material they say 17 amps. That's why I stay to 17 amps. Now, if you tell me go higher, I will tell you that you are nuts. I won't go higher. That is all, guys. If you have any questions, leave them. Oh, you have to say that.
subscribe. Good luck.
So, guys, any questions, just leave them in the comment section. Bye bye.